Good morning! Today we answer a very simple yet not so simple question. What is light? It's something that passes by us every day, but we don't really pay attention to it. Kind of like our teachers. First we have to break it down into three sections. How it's made, how it travels, and how it's a particle and a wave at the same time. So let's get started. To create light you need energy or heat. So let's go to a place where a lot of heat is generated. Cue the clip. These welders are using an alloy of carbon and iron. We know that once these pieces of metal are heated up, it begins to give off light. But how does this work? So let's look at what causes these iron atoms to light up whenever they're heated. Let's look at this poorly drawn iron atom. Each of these yellow rims are energy levels, and once these atoms are heated up, these electrons jump to higher energy levels because they're so full of energy. So think of my hand as the nucleus or the center of the atom, and this ball that I'm swinging is the electron. Once you add more energy or heat to the atom, the electron will begin to move faster and farther away. So maybe these electrons on the fourth energy level would jump to a fifth energy level. Once this electron goes to the fifth energy level, it's stressed and it just wants to be relaxed again. So it goes back to the fourth energy level. Then this energy has to go somewhere, so it's released as a photon. But wait, what's a photon? Well, photons are these little packets of energy that are released whenever the electrons move back down a level. Each of these photons have a different frequency depending on how much energy was released. If it was a lot of energy released, then the frequency is high. If it's a little bit of energy, then the frequency is low. Our eyes have adapted to detect certain frequencies as colored light. So this is actually how light is created. And how do these little packets of energy travel through space? All energy needs a medium to get places, like how a power source uses wires to get to light bulbs. The wires would be the medium. So then where's the medium in this pure energy? This is where things get spooky. These little packets of energy can be particles and waves at the same time. It's called particle duality. Let's look at how these photons can act as both particles and waves in separate experiments. The first one being how it acts as a particle. Okay, let's take this simple experiment. Two plates are electrically charged, negative and positive. Now, once these metallic atoms are excited with the electricity, they're going to release all of these photons through the slit, and we're going to be able to see where they're going. Neither of the plates are lighting up, and there are no wires connecting them to the sheet. So these photons are acting as a medium or a particle to transfer the energy. Now the second project involves something radioactive, a thick lead box with a hole in it, a sheet with two slits, and a sheet to show where the electrons are going. These electrons actually landed in these positions. But how? Once these waves of electrons act on each other, these gaps show where they were cancelled out, and the green was where most of them landed. So this is on how electrons and photons act like waves.